Okay, so in question number 5, follow-up number 5, we are looking at some solid calcium hydroxide. We dissolved it in the water, and you can see I've sort of drawn little particles of calcium hydroxide. Obviously, there's so many more of them in order to make it. What do those little solid particles do? What do they do with the light? Yes, the light bounces off of them. And what does that cause your mixture to look like? You can't see through it. It is cloudy, okay? However, you heated it up. Did all of the calcium hydroxide stay in solid form? It is slightly soluble, so some of it dissolved. And when ionic compounds dissolve, it is as though we had our crystal lattice, and if I could just pick the ions off one by one and fling them into solution, they would all be, the ones that have dissolved would all be separate from one another. Does that make sense? Yes. So this here was our heterogeneous mixture. What did we do with it after that? We heated it up and we dissolved a bit more of the calcium hydroxide, and then we filtered it. Okay, so we filtered it. And we had our filter paper in here. And what ended up on the filter paper? Just calcium? The calcium hydroxide, the stuff that had not dissolved. Okay, so on here we have undissolved calcium hydroxide. When we have that on the filter paper, this is called the solid stuff that's on the filter paper is called the residue, okay? Because we need to have names for everything, yes? Okay? So there's our residue. And down below we had a beaker. And was this cloudy or was it clear? It was clear. In other words, it was transparent. Excellent. And if we go back to our little diagram here, which of these particles got stuck on the filter paper? The little solid ones, yes? Now, it is unfortunate that I can draw a solid particle really small, but when I draw an ion, because it says Ca2+, can I draw it really small? No. In reality, what it would look like, in reality, we would have our solid bits, which would be like this, yes? And then you would have the ions, which are like, la, 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 la. Yes? So that is a more to size drawing, okay? If you could zoom in. And they are teeny tiny. Okay, these little red ones. The solid CaOH2 particles are much, what? Bigger. Okay, so these get stuck, the solid gets stuck on the filter paper. And what do we call the stuff that's stuck on the filter paper? We call it the residue. Okay, but the ions, they are so teeny tiny, they fit through the filter paper. Okay, and that means that once we have filtered it, what will actually be in our beaker? There's water and what else? Ions. Yep, so we're going to have our Ca2 plus and our OH minuses. So now we have this clear, transparent solution with individual ions floating separately. Are they big enough to scatter the light? No, they are too small to scatter light. And this stuff, this clear liquid that comes through the filter paper is called the filtrate. Okay? water has a slightly negative end and a slightly positive end? Yeah. What does it look like? On an atom level, you want to see? Yeah, yeah. We'll actually go more into this in the next unit, but here's a little teeny tiny preview for you. So you would have your calcium ion and your water. This is the oxygen. It is what we call slightly negative. That little D, it's the Greek letter delta, lowercase delta. You guys are familiar with the triangle for delta, right? That's the capital delta. This is a lowercase delta, and that little D that almost looks like an S, it's lowercase delta. It means slightly or partially. So that end is partially negative. That is our oxygen end. And then the water molecule has hydrogens on one side. They sit there like Mickey Mouse. Yes, so they're not like, you know, it's not a linear molecule, it's actually bent. Okay, and they are slightly positive. Ah. Oh, come now. Don't misbehave like that. Come on, there we go. Okay, so they are slightly, oh, now it's really unhappy. Okay. Yeah, I just can't write on very much of the whiteboard because I'm like, I'm too short. But maybe that's what we're going to have to do for the moment. I love it so much. Ah, there we go. Slightly negative or positive. Oh, that's easy. I can change those to positives. There we go. And so when you have your calcium ion, the slightly negative ends will orient themselves towards the calcium, and the slightly positive ends will orient themselves away from the positive calcium. And then, of course, when you've got your hydroxide, it's going to be the opposite way around. Where these slightly positive hydrogens will orient themselves close to the hydroxide, and there will be intermolecular forces between the water molecule and the ions. Is lovely? Yes. That one, I've got some lovely videos coming up for that one in this unit and in our solutions unit. And sorry, in the next unit and in our solutions unit. So, yes. Okay, so here we have our filtrate. It comes through. What kind of a mixture is the filtrate? It is a homogeneous mixture. Now, we've sort of talked about all of this before, so why are we talking about it now? It's because follow-up question number 5 says, you dissolved a solute in some water to make a solution. If you needed to know how much solute dissolved, how could you determine this? So I want to know, right, because not all of it dissolved. Yes, only some of it dissolved. How could I figure out how much actually dissolved? Yes. Okay. Okay. You're on the right track. Yes. Yes. And what I would say is that because this solid is in powder form, finding its volume is really awkward. Yes, because there's a lot of like air pockets in there and different sizes and whatnot. So instead of using volume, you would use mass. Yeah, okay, so did you guys catch what happened there? No, and that's okay because we're going to walk through that. So what you would do, you would start and you would say, I want to know, I'm going to find the mass of the calcium hydroxide. Yes, I'm going to weigh it. Yes, yeah. Yeah, it's not so good. So you weighed it, yes? Then you dissolve, as in the lab. You don't have to go into details there, you just did the lab, right? Now, if you want to know the mass, you've got the initial mass of the calcium hydroxide. You want to find the mass of calcium hydroxide here, the stuff that did not dissolve. Yes? Can anyone, could you just take, you know how you had your residue yesterday and it was on your filter paper? Could you just throw that on the balance and be like, okay, I got it? What would you have to do first before you could weigh this residue on the filter paper? Pardon me? You have to measure the filter paper first before you pour anything through it, do anything like that, because you know, I've had people suggest that they could scrape off the solid, but it gets really in there and you know, it's really stuck to it. So it's best to measure the filter paper first. So we're going to put that in there. Tell your partner what comes after measured mass of the filter paper. What are we going to filter out? We're going to filter out the, what are we trying to get rid of in our homogeneous mixture, or sorry, heterogeneous mixture? The undissolved CaOH2. Yes, 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 yes. Now, can we just throw that on the balance and weigh it at this point? What should we do next? Tell your partner what you think we should do next. I'm not assuming anything. We have filtered out the, we have poured it through the filter. What next? Once you've finished writing that, chat with your partner. What do you do next? This next step is easy. What do we have to do next? Take the paper out? Well, yes. So we've taken the paper out of the funnel. What now? What does it feel like when it comes out of the funnel? Feels wet. Shall we just throw it on the balance? What should we do? We should evaporate the water. You should either leave it out to dry or put it in a drying oven. Somehow or other, you want to evaporate the water, okay? So you've evaporated, you've left it out to dry, or you've put it in a drying oven. And now what? Weigh it. Yes. Find the mass of the, what are we weighing? Final mass of what? Just calcium hydroxide? And the thingy, so you're finding the mass of the CaOH2 and the filter paper on balance. That was nice. Are you done? Yeah, you have to subtract the mass of the paper. Thank you. Because I can count. Sure. Degree in biochemistry, but I can't count. It's all right. Subtract mass of the paper from mass of paper plus CaOH. 2. Done. Plug it in. There you go. There is another way. There is a second way to find out how much is dissolved. And it will involve using the filtrate instead of the residue. Yeah. Mm-hmm. So I'm going to let you brainstorm about that one for a minute. Okay, so chat with your neighbors, and you can also, if you're not having any luck with the person beside you, you can turn around and talk to the person in front of you or behind you as well, because more brains are better than fewer brains, right? Nope, not complicated. Actually, that is another way. You could do that too. You could. You could actually, there's a process called titration where you titrate the solution. react hydroxide with hydrogen, and then there's an indicator that will change the color. So there are actually several ways, but I'm just thinking of things that we can do given our very limited knowledge so far of chemistry. So what it actually does is it changes color once it goes from acidic to basic, or basic to acidic, the color flips. From, it'll be pink, if you use phenolphthalein, it's pink in base, and then it turns colorless in acid. That would just tell you that there's that but it does really yeah. This is like 4 units down the road. No, sorry, 6 units down the road. So you find out how many particles you have. Then you know that hydrogen peroxide reacts with water. So now you know the amount of hydrogen, you know the amount of peroxide. And yeah, and if you know the amount of peroxide, you know the amount of calcium hydroxide, because there's one calcium hydroxide for every hydroxide. And then you say, oh, well, if I have that much, then I must have hydrogen for mass. It's concentration. Chemistry, all of those. It's still over my head. I just have to basic. But that concept of ratio is where it's all about. Yes, you do. Where did I put that? I put it somewhere clever. There you go. But we're even simpler than that. Has anyone thought of a method? Yes? We could measure the amount of water that comes out. We could. But we actually, so what we want, if we've got our filtrate, let's visualize our filtrate again. Remember, it's got water, and it has Ca2 plus ions floating around in it, and it has OH minus floating around in it. But you can't see these, and I want to know how much of those dissolved ions are there. Is there any way I could separate the ions from the water? It's like a really easy method. Ooh, who said that? Evaporation. That's okay. The back row said it somewhere in there. Okay. Unless you heat it. So you're going to dry this out, okay? So what you would do is you would, first of all, you would need to measure the mass of the beaker, yes, before you filter into it. Because otherwise, once all the liquid's evaporated, you're going to be like, okay, well, that's great. I've got the mass of the beaker and the dried up ions, but like now I need to subtract the mass of the beaker. And if you don't have that originally, then you have a problem. Just like if you didn't weigh the filter paper ahead of time, you would have a problem. Evaporate the filtrate to dryness. And then you would measure the mass of the beaker plus the dried up ionic compound. And if you're like, I don't really want to evaporate this much, that looks like a lot, you could take a smaller sample. Like you could find you could say, I have 100 milliliters here. I'm going to take 10 milliliters and evaporate it and measure the mass. And then I can just multiply by 10 because I have 10 times as much volume. Yes? I refiltered the stuff you guys gave me yesterday, some of it anyway. And I'm just going to put some of it into another, what kind of flask is this? Starts with an E? Erlenmeyer, yes. Erlenmeyer isn't too bad as long as you remember that every syllable has an E in it. Erlenmeyer. Oh, look! What's this contaminated with? What was this flask contaminated with? Phenolphthalein, that indicator that turns pink in base. So maybe I won't use this one to do that particular demonstration. It won't show up quite so well. Let's see if I can find a clean one. You're scared of what? Okay. All right. Okay, so what I'm going to do is I'm going to blow into, I'll steal this straw here, silicone straw, so that we can reuse it. And I'll turn on the lights so you can see a little bit better. And hold it up against the black. We're not tasting this. There's no inhaling involved. Okay? So, we have the black background, yes? I got the straw. Oh my God, this is complicated. Okay. Clear, yes? Colorless, yes? What has happened? It has become a mechanical mixture. Once again, what must be in here to be making it cloudy? Tiny little, what state of matter has to be in here? What state of matter? There have to be tiny little solid particles in here to be big enough for the light to be bouncing off of it. So once again, we do not have just a solution here. Now we have there's little solid particles suspended in here, so we call it a suspension, yes? Yes. And who made the suspension? Ms. Spence made the suspension. Oh my God. All right. Now, you are not technically responsible for the reactions for this. However, I will show you the reactions in case you're interested, okay? Because there's some complicated stuff going on in there. All right, so we have, oh, where'd I put my glove? What am I exhaling? CO2, yeah. So in my flask, I have Ca2+, I have OH minus dissolved, and I am now exhaling CO2. When CO2 gets together with water, it can actually form, if we take all of those elements and cram them into one formula, what do we get? How many H's? 2. How many carbons? How many oxygens? 3. What kind of a compound is that? It is a covalent compound. It's a little more complicated than that. It does funny things. We'll talk about it later. But it has hydrogen at the front. What kind of compounds contain hydrogen? Acids. This is an acid. Okay, and it's an acid based on the H plus ion and the CO3 2 minus ion. Do you guys know the name of CO3 2 minus? Carbonate, yes. So that's carbonate, and if we make an acid with it, it is called carbonic acid. But it doesn't stay as carbonic acid. It actually, once we get our H2CO3, it actually separates. And again, this is simplified into H plus and CO3 2 minus. So the ions split apart. And carbonate is especially low solubility with calcium. And remember, what did we have over here? We had calcium. So these two guys are actually going to get together and they're going to form calcium carbonate solid. Okay? Are you responsible for knowing any of that? No. Is it a little bit interesting? Okay. It is pretty cool. This is actually when we have a solid form where there was no solid before. We call that a precipitate. And that is a word that you will use many, many times in the future. Precipitate, a solid that forms where there was from a reaction, like not because it just a solid that forms during a reaction. During a reaction in aqueous solution, yeah. In aqueous solution. That is not an awesome definition, but are you responsible for that definition? No. Okay, so all of this is just like extra. Yes, it's just there because it's kind of nice to see how things work because then it won't look completely foreign when we actually study it. Yes? Okay. Nathan's asleep. Like, I think he's seriously asleep. I wonder if there's drool. That would be kind of fun. Anyway, sorry. I'll leave him alone. All right. Yes. So that's it for that question. Your conclusion. You know what? This lab doesn't really need a conclusion. It was more about like observing stuff. So if you wrote a conclusion, that's fine. But I feel like this was more of a skill-based lab than a with equipment in the classroom, with homogeneous and heterogeneous mixtures, with safety procedures, how to light a Bunsen burner, all of those things. And you get to see some cool chemistry in the meantime. You get to see that that clear colorless liquid turns pink if you have the wrong stuff with it or the right stuff, depending on. Okay. So that lab is due on Monday. If you're finished it right now, you can hand it in right now, but the lab is due Monday. Huh? No conclusion, not unless you want to. If you've already written it, that's fine. Okay, so if anyone has it ready right now, I'll put out my little tray. You can hand it in here. But you can definitely like take it until Monday. Yeah. Huh? Yeah. That looks good. I don't know. Fine. Just hand in what he's got. This is not a hugely formal lab. Oh, you need to answer follow-up question number 5. Ladies and gentlemen, you must have answered follow-up question number 5 to hand in your lab, yes? Yes. Okay. Are you all done? Have you answered follow-up question number 5? Okay, perfect. There you go. Hi. Oh, we're out of staples. Here, let's get more. There we go. Anyone want to use the automatic stapler, the electronic stapler? Oh, what's it doing? No, here we have to tilt it out. Turn it over. There. Like, why is it not working? There we go. Anyone want to try the automatic stapler? Yes.
What should I do?
No, you're supposed to draw pictures of the procedure. You got that? So it says draw the procedure. Right. Draw the procedure. Yes? Okay. Yeah. Just right here. Excellent, thank you. Yes. Uh-huh. Okay. We now have completed our Yes? So if we go to our team, we can see the outline for your test, which is basically if it is in the book, it is on the test. However, it's going to look a lot like if you took all your quizzes and stapled them together, right? The only thing is that there is section 1.3, which is on solutions, but we've just spent a whole bunch of time talking about homogeneous mixtures and heterogeneous mixtures and filtrates and things like that, yes? Your test is on Tuesday. Now let's just look. You can do a re-quiz on Monday if you want to, yes. Do we have retests? No. What will happen if you are away on the day of a test? I will be taking note of your name, and if you miss a second test, for that second test, you will get a harder version, unless you have like a doctor's note. Do you know what I mean? Because there are those people who are consistently away on the day of a test, and that is no way to live your life. Number one, it's a pain in the arse for me, yes, because I have to then find a time. I've marked all of question one. Now I have to find the answer key again. It's awful, okay? Like not having things all in one package is awful. Second thing, it's actually really bad for you because students who do that on a regular basis generally do very poorly because they're always behind and they're always trying to catch up and they're never kind of where they need to be. And once we moved on to the next unit, now they're behind in the next unit because they were trying to get caught up on the unit that they didn't learn in the first place. Yes? No. Because that means I have to make a harder one, and that's a pain for me as well. Yeah, pretty much. So basically, if people skip my tests, if they cheat on my tests, you will discover that your version will be a personalized version that will be harder. Okay? I actually had some students once who stole a copy of the test, grade 12, stole a copy of the test, looked at it, somebody narked on them. Love that. If you ever want to narc on someone, I'm your girl. You want to tell me because I love it. I'm like, yes. Okay, so I knew that they had seen it. So I gave them a completely different test. Grade 12, I actually know the percentages that each question would receive because there used to be provincial exams. So I know how hard each question is. And I have a bank of thousands of questions that I can choose from. So I just chose all the hard ones. So they came in all ready to write their test. They're sitting there. I put them right in front of me because they're cheaters. And they're glancing at each other what the hell is this? This isn't what we saw. And oh my God, it's so hard. So they're sweating and oh my God, it was excellent. It was great to watch. Okay, but here's the best part. Later on, the two of them came into me and they said, after they'd gotten it back and not done particularly well, they're like, we noticed that we had a different version of the test and it was a lot harder and we don't really think that's fair. And I said, is that really what you want to talk to me about? And then they talked to each other a little bit. And I said, is there anything else that you'd maybe like to talk with me about? And I'm like, I really appreciate honesty. Honesty goes a long, 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 long way. Anyway, eventually one of them caved, and he felt really bad. You could tell, there were tears. He went and he told his parents about it. There was a whole thing. In my heart, I was like, this boy deserves good things from this point onward. Okay, because unless he was like a complete psychopath, and he wasn't. I mean, I'd known him for a couple years. He had been led astray by the other boy. The other boy, I don't think cared. I think he probably was a sociopath. 1 in every 100 people is a sociopath, so it's not too unlikely to run across one. He pretended he was sorry. He's like, oh, I'm sorry. Oh, my. You know, there was a whole thing. I'm like, oh, those crocodile tears are really like, you know. Anyway, so yeah, don't mess with me. Yeah? I will do, if you do really badly on your test and you want to come in and do corrections, I will be happy to sit with you so that you can learn from it and do some corrections and get some partial credit on those questions. I want you to learn from this. I don't want any cheaters or skippers though, because it's a toxic thing for you to do for yourself, and it's really hard on me as well. As much as I say I delight in it, I actually really hate it when students cheat, because then I'm like, oh crap, now I gotta deal with this. You know what I mean? Like it sucks. I mean, as much as I say I love doing it, I don't. It's actually quite stressful. So don't cheat, don't skip. I do understand that there are people who are sick. Please have your parents send me an email, okay, personally. That would be great. Just don't be away a second time on a test unless, again, you're really, 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 really sick. Yeah, okay? Yeah, if you're dying, you know what? If you're throwing up, I would like you to stay home, yes? And honestly, it is COVID time. If you are sick and coughing and whatever, you should stay home. I don't want you to come here when you are sick in order to like not feel my wrath. You will not feel my wrath. I'm a reasonable human being. But just, you know. Okay, so here we go. Where is your upcoming quizzes and tests? Here we are. So take a looky here. We have our test on Unit 1 on Tuesday, October 4th. Basically, it will be the same as, similar to the quizzes, I have attached blank versions of all the version A of all the quizzes, so you can just like redo them, okay? They're just there for you to, like if you want to take it and just, you know, open it up and practice. You have your own answer key because you have your quizzes back. If you have lost it or whatever, send me an email and I can give you a key. Plus, there will be some vocab relating to section 1.3 matter and solutions. So that would be like the stuff we did. You know those diagrams where you had to recognize if it was an element or a compound, pure substance or mixture? That kind of thing will be on there as well. Okay? Alrighty. Are we good? Are we ready to start Unit 2? No. No. Otherwise, the test has to be on Monday because we're done today. Shall we start on Unit 2? Here we go. Hold on. Okay. Yeah. So, if you've not yet gotten one of these, that's good news. It means you've paid for your workbooks and you get to keep it and write in it and all that stuff. If you just did receive one from me, you don't get to write in it unless you come and show me a receipt for having paid for it, because the printing company will not be happy if I don't pay them. Yes? So you need to pay the office in order that I can pay them. Don't forget, if it's a financial hardship on your family, you can ask your counselor to have the fee waived. If you are international, you do not have to pay. Everyone else can just come grab themselves a book, and everybody can come get an answer.
If people in the hallway see it, find a way to always swing their arm No, I don't know. I was thinking. You too? So ungrateful. So ungrateful. Like I think you're filet mignon.
So, where are we at? Unit 2. So, you know what? Today we'll do something really simple. Rounding numbers. Okay? Rounding numbers, like easier than you could imagine, and yet people do it wrong, which makes me cry. Okay? So, rounding rules. We actually have that. We are using the easiest rounding rule. Basically, identify where you want to round to. Okay, in this particular case, we have put boxes around the digit that we want to round to. So in the first example, I want, yes? Not on rounding. Oh, actually, yes, we are. And not everybody gets 100% on it. Seriously, oh yeah? I kid you not. It is very common for people to get things wrong on this quiz, and I will show you why in just a moment. Okay, so we are going to round to the 8. All right, and so we look to the right of the 8 and we say, what's that number there? It's it's another 8. Is that bigger than 5? Yes. So what do? We round the 8 to a 9. Yes? Okay. And then if we do the next one, we say, oh, I've got a 1. Yes. And the digit beside it is a 0. So we are now going to round that to 1,000. Okay? I know this is so hard, right? Now, if I have 12,450, what is the digit to the right of the 2? A 4. Do I round up or down? I round down to 12,000. Now I have 3,300 or the 300, and I don't know what that number is. Anyway, it's a big number, and I want to round to that digit. I want to round to the thousands position. And so there we are. Yes? So far, so good. Yes? I've got a 4, so that's going to stay as a 0. Okay? Now, if I am rounding this to 3 sig figs, and this is why it gets hard, is that when I say, let's round this to 3 sig figs, now you have this number that would come out of this, and it would be 400,000, yes? That is not entirely correct if I say round it to 3 sig figs, because that has how many sig figs? 1. So I can make it 3 by doing this. Is there another option? I could put it in scientific notation. I could say 4.00 times 10 to the 5. But I'll tell you what I often see from people. They're like, okay, I need 3 sig figs. And I'm like, 400 is not 400,000. Like, they just sort of get rid of those zeros. They just go away magically. And I know you're laughing now. You're like, how could anybody do that? I swear to you, probably 2/3 of you will do it at least one point, okay? Taught this for enough years, I know what happens. The other thing that I see people do is they double round, right? So if we're going to round 749 to the hundreds position, then we look to the right and we say it's a 4. Often people will say, oh, well, there's a 9, which rounds that to a 5, which rounds that to an 8. Only look one digit over. Ignore everything else. You can just ignore this. It is as though it were not there. If you think on a number line, right, if we actually had a number line, did I draw a number line? Bless me, I did. Okay, look at that. I was thinking ahead. Here is my number line. And I am going to be rounding either to 700 or to 800. Is 749 closer to 700 or is it closer to 800? It is closer to 700, so I'm going to round to 700. Okay? Now, 750 is at exactly halfway, so if we had 750, we would actually round it up just because we're going with the simplest rule possible for rounding, which is if you have a 5, you round up. If you go to university, what they'll do is they'll say if you have a 5 and nothing afterwards, like if it's 5 with just zeros after it, you will round to the even digit. Yes, but we're not doing that, so just pretend I didn't say that. Yes? Yeah, well, that's essentially the same rule. Yeah, it's the same rule, just expressed differently. You'll always round to the even number. Yeah. Do not just cut the number off, okay? So if I say, let us round to 3 sig figs, this becomes 335,000, not 335. Those digits at the end just don't go away because I don't know. It may look ridiculous to you, but you would be surprised how often students do this. Okay? When you are rounding, I would like you to use an arrow rather than an equal sign, or you can do an approximately equal. Yes? Yes. Oh yes, back to the other example. Oh, because I can't type. That should be a 4. Thank you. This should be a 4. 4 and 5 are beside each other. They use the same finger on the keyboard. Yes? I loved typing class. When I was in high school, in grade 10, I took typing 9, and we had old mechanical typewriters. Literally, there was a carriage return. So when you got to the end of the line, it went ding, and you would go ka-chunk. It was amazing. So much fun. And there was so stress-free. There was never homework. There was like practice your typing. But me and my friends, we'd all taken piano, so we were all like okay at it, right? You didn't have to be awesome. Oh, it was the best thing ever. Dexterity, finger dexterity. Yeah, that's all it is basically. No. Okay. You can use the overbar or you can use scientific notation, right? So all of this is coming back, right? Scientific notation. So here are some exercises which you could do for the rest of the class. If you finish early, you're just done. Okay? Sound good? What are you doing over the weekend? Studying for your test. What are we doing on Monday? We are not having a review day. We will be working on Unit 2. Okay? So study over the weekend. If you have questions on Monday, I will be happy to answer them. But I will not be teaching or giving a review block because we've written quizzes and we've rewritten quizzes and I don't feel like we need a review block. And you go home over the weekend, you got 3 days of review block. Yeah? Always answer sig figs. Always. Unless it says not to. You do not need to write how many sig figs are in the thing. Not on me. Okay. But I might be able to find you something. It's okay, it's okay. I'll take a look. I'll see what I've got over here. I have like leftovers. Yeah, if you have any leftovers, yeah. But if you don't, then you don't need to. Okay. And that's all part of it. Okay. But that'll be next week. Yeah. Okay. Oh, you know what? Don't worry about it. I'm just going to that. Yeah. I do not what? You can use scientific notation, absolutely. Love the scientific notation.
Exactly. That's my point. It depends on what teacher it is. I don't know what teacher wants. Teacher one, teacher one.
Yes.
That's not saying that.
That would be a 50, right? So it should be 5, 0, 0. Yes. And now, in order to have it 5 days, or you can write it inside so how would you write? Right? 5. You don't want that one to be 6. 5. Yes? Now you're going to do 9, here, that's 5. What do you think? Sorry, what?
I retake the quiz.
Yeah, I haven't marked it yet. If you send me an email over the weekend, I can probably give you your score. But I won't remember, so you need to email me. And even then, I might not remember, but I'll try. Depends if I remember to check my email. Hi. The requiz over the weekend. Yeah. You can email me, and I might remember to check my email. If not, Monday. I don't know. Yeah. Give me a day or two. Yeah. What are we doing today? Combustion analysis. Hi.
I woke up I put my alarm for 6 o'clock,
Yes.
and then I woke up at 8.
It's okay. These things happen.
I will probably come on Monday.
Okay. Sounds good.
I have a cross-country meet right now.
Yes. I will make sure that I press stop